Okay, chapter 12. Introduction to Parametric Functions. Okay, so where did it come from? Suppose you have a particle, suppose you have an object moving in xy plane. So your particle is here, then it goes here, here, then move here, and it's a continuous movement, change of position for your particle. Very well. So you have x-axis, you have y-axis. You can find the location of this particle in xy plane. It is here, xy, then it moves here, xy, xy. It's not that hard for you to find the position, x coordinate, y coordinate of this particle. So I expect you to ask, what if I want to know at time 0, where is the particle? What is the location of the particle? At time t in general, what is the position of the particle? So what are we doing? We are actually defining a new parameter or a new variable. So this t is a new variable. So here's an idea. Why not defining these two coordinates, x coordinate and y coordinate, be function of variable t? So we're going to define x coordinate and y coordinate to be functions of variable t. This is the general idea about parametric functions. For example, let's give you one example, see what's going on. Consider the following parametric equations . What I'm doing, defining x coordinate and y coordinate using a new variable. Suppose I define x coordinate to be function cosine t, cosine of t, and I'm defining the second coordinate, y coordinate, to be sine t. And I'm saying that that t, which in this case is the angle, not the time, the angle is in between 0 to 2 pi. Question says, describe the graph of this particle. Describe the graph. Okay, so let us get back to trig functions, trig identities. Here you have sine and cosine. You already know that, sine squared plus cosine squared is always 1. Sine squared alpha plus cosine squared alpha is equal to 1. If I have the same angle, alpha, sine squared plus cosine squared is equal to 1. Since I have t and t, I can take each of these, raise them to the second power, add them together, the outcome is always 1. So what is my cosine? My cosine is equal to x. So this guy is now x squared plus What is my sine? Sine is y. I have y squared. This is equal to 1. What is this equation? X squared plus y squared equals to 1 is just a unit circle. So this is your graph. The graph of this particle is a unit circle. If I plug in 0 for t, I just want to know what's the starting point. So if I plug in 0 for t, x is equal to cosine 0, which is 1, and y is equal to sine 0, which is 0. So the starting point is 1 and 0. This is the starting point. My particle starts at this point. It rotates around x-axis along this unit circle and stop at this point. Very well. Let's go over another example. Example. So, what's given here? A parametric equations for a particle is given. So it says x coordinate is square root of t, and your y coordinate is just t. And suppose t is greater than equal to 0. Describe the position of this particle. Very well. I have x, I have y. It's not that hard, just don't overthink it. X is equal to square root of t, and y is t itself. So wherever I see t, I'm going to substitute y. So my x is equal to square root of y. So if I raise both sides to 2, I get x squared equals to y. Very well. Note that since t is positive, your y is positive. It means that on xy plane, we do not work with negative sign. And at the same time, since y is positive, your x must be positive as well. So we do not work with the negative side of x-axis. So you have y equals to x squared. You all know that it's a parabola, opens up. And since we don't work with the left-hand side, it's just right-hand side of parabola. X is positive. This is your x-axis. This is your y-axis. So now that we have a new type of function, parametric equations for a function, I expect you to ask, how do we take the derivative of these types of functions? So the derivative of parametric equations. So the first derivative of any parametric equations is defined this way. Y prime is dy over dt divided by dx over dt. Let's take this parametric equation and find the derivative of this function. Y prime, the derivative of y with respect to t, which is 1, divided by the derivative of square root of t, which is 1 over 2 square root of t. So the derivative of this function is 2 times square root of t. Previous example. The second derivative of a parametric equation can be defined as the second derivative of x with respect to t times the first derivative of y minus just rewrite this way. So the second derivative of y with respect to t times the first derivative of x with respect to t minus the first derivative of y with respect to t times the second derivative of x with respect to t divided by, now we take the first derivative of x and raise it to the third power. The formula for the second derivative of parametric equation.